Hey guys, it's me again. Hopefully your textbook on chapter 4 is going well. Here is a overview of the stability of population section, pages 123 and 124. So on these pages, it is talking about stability of populations. So let's get started. Maybe doesn't want to go. There we go. Okay. So stability of populations in ecosystems. The stability of populations in an ecosystem can be affected by many factors. For a population to be healthy, factors like food, nutrients, water, and space have to be available. These are resources that living things need. And without them, they can't survive. If there is a low food supply or lack of space, these are limiting factors in an ecosystem. So what is a limiting factor? Limiting factors are conditions that can prevent the growth of a population, or this word abundance, meaning how much of that population we have. So limiting factors can have living factors like biotic, our vocab word we've been learning, and non-living factors or abiotic features in an ecosystem. So for an example, a limiting factor, water. Water can be a limiting factor. It changes the amount of moisture an area gets year by year. So if a lake receives less than expected precipitation one year, that water level goes down. And so that space where the animals were able to live is now limited because there's less water in the lake. And so now they have only this much space to live in instead of their amount that they used to have. And so now they've got to interact and get along in a closer setting. And so this can cause a change in their growth because they don't have as much space to live. So remember our vocab word biotic means living. So if there's a change with any of the factors, then food can become a limiting factor as well. Like less rain is going to mean less plants growing, which means those animals that are surviving off of those plants are going to decline because they don't have as much food. And if a population of animals decline, then whatever animals eat those animals will also go down. So it's just this trickle effect going down and down throughout the food web, causing all populations to change because there was this limiting factor that came into play. Invasive species is another thing. It's not mentioned in your textbook, but it's definitely something that can cause a change in ecosystems. So this is cheatgrass, and it's an invasive species. That means it's not native to that area. So native means it was born in that area or raised in that area. So for Utah, for example, we have species that they belong here, you could say. They have all their resources here. We're not going to find an elephant living in Utah naturally. So native species are species that are originally from this area. An invasive species is something that wasn't originally in this area but was introduced by some factor, like a human came by and planted this plant and it did really well, and now it's overtaking the native plants. So invasive species are really good at competition, and they are really good at getting all the resources that they need. They get their food supply, they get their space, they get their water, and they don't care if other living things need that too. They invade their space. It's like when somebody invades your personal bubble and you're like, whoa, you're in my space. Invasive species do that. So then in your textbook, it shows a picture of bunny population with and without predators. On page 126, it's asking you to evaluate this section. So I just wanted to talk about it. Your textbook says, these graphs show the population of bunnies over time in an ecosystem. After learning about stability and change in ecosystems, construct an argument using evidence from the two graphs for the changes in the bunny population in the two scenarios. So this scenario is a population that does not have predators feeding on it. And so because of that, we can see if a predator isn't eating the bunnies, well, the bunnies are going to be living healthy and they're going to be able to reproduce, meaning there's going to be now 2 bunnies for every 1 bunny. And then those bunnies are going to reproduce. So we have a population that starts to grow and increase and do really well. This is what we see when there's not very many predators or predators at all feeding on bunnies. Now, if we introduce a predator to the area that eats bunnies, the bunny population is going to go up. But then when predators are introduced, the population starts to decrease because predators are eating the bunnies, and so their population goes down. Once there's not enough bunnies to eat, the predators also will die out, and when there's not enough predators again, then the population of the bunnies go back up. And as the populations of bunnies go up, the population of its predator is also going to go up. And so that's why we see this up and down is them doing well and their predators doing well. The predators overeat, causing the decline of the bunny population, and so forth. So, your assignment for today. Let's get that typed up. How do I exit out of here? Oh, there we go. Okay, so your assignment for today is to read pages 123 and 124, and then you're going to complete the focus questions on page 125. And then we just went over the graph on putting it together, so you'll complete the putting it together on page 126, and that's just constructing an explanation for what those two graphs are doing. If you have any questions, feel free to email me and I will get back to you as soon as I can and do my best to explain those over our digital learning. So have a good day and best of luck. Stay healthy. Miss you guys.